Hey everybody, welcome to our explanation of the dissolving plastic. First, we're going to start off with a little bit of the slow motion video of the foam sheet in the acetone. And you can see as it hits the acetone, you see little air bubbles start to pop up. And eventually it really starts going and you see a lot of air bubbles from both sides of the foam. And within really a few seconds, the foam, the plastic, is pretty much totally dissolved and becomes like a goopy mess. So now Maya and Maddie are going to explain a little bit of the science behind what is happening there.
Hi everyone, my name is Maya and this is my sister Maddie, and we're here to answer the question, why does acetone dissolve foam? The answer to that is there are chains of PS molecules.
What's PS stand for?
PS stands for polystyrene, which is plastic. So, the PS molecules have air inside them, like trapped inside, and when you put the foam inside,
Don't do it yet. Good.
Inside acetone, the chains break, which allows the air to go out, which creates lots of air bubbles in the foam.
All right, so let's show people some air bubbles being made. So if you put the cup there, you'll see little air bubbles, and the cup dissolves pretty quickly. And then what's left behind,
We'll
is
show
sort of
you
this
when this
goop. And that goop is the plastic with the air removed. So continue watching this video to see a little bit more of the specific scientific explanation to why acetone dissolves foam. Thank you very much. See you later.
Bye, everybody. Bye. Bye.
Okay, so here we have a little bit more of the detail. So we have plastic, and plastic is made up of something called monomers, and those monomers are made into a long chain, which is called a polymer. The polystyrene molecules are linked together in a long chain. The polystyrene molecules are linked together in a long chain, and they're wrapped around a pocket of air. So here you see the air pockets up close under a microscope, and you can see those little bubbles. The outside of the bubble is the polystyrene, the inside of the bubble is the air. So when it's undissolved, the foam or the plastic, it has that air trapped in the middle, surrounded by the purple circles there, which represent the polystyrene molecules, and the acetone is represented by the blue circles there, which are there around it. And once it gets a chance to interact with the polystyrene, the chains that are there of the polystyrene are going to be broken apart, so the air is going to be able to escape from that little pocket of the polystyrene. And so when it's dissolved, it is going to be taking up less space and when the air is released. So when the air is gone, the polystyrene molecules collect together inside the container, and they're still there, they're not destroyed. So now back to our questions. So why does acetone dissolve the foam? So acetone and polystyrene, when they're put together, the acetone breaks up the polystyrene chains. Then the air is released and the polystyrene remains behind. So why does it take longer to dissolve the cups than the foam sheet? Now, if you notice in the original video, we played with all three of these, and you could see that there was a difference between the sheet and the cups. So if you look on the bottom of a styrofoam cup, or even that other clear plastic cup, you'll see a number, and that number is surrounded by that triangle, and that number 6 represents polystyrene, and you can see the PS that's also stamped there on the bottom of the cup. So under the microscope, the foam sheet on the left has larger air pockets, more air, and on the right you have the microscope image showing the cups, and they're more packed together. There's more polystyrene chains, and actually there's less air. So the cups have more polystyrene chains, less air, so that means that it takes longer to see the effect with the acetone. So it takes a little bit of time for those chains to be broken, and there actually isn't very much air, so it doesn't shrink all that much. So it takes a little bit longer to dissolve, and even longer for the clear cup than the foam cup. And that's it. So thanks for watching. So one last thing, special thanks go out to Quentin R. in the 8th grade for special inspiration on this. This was actually his science fair project for this year. So thank you very much for all that inspiration.